Going to begin talking about some inverse functions today. So inverse functions. Earlier in this unit, we have already determined how to find out if two functions f and g are inverses. If we took the composition of those two functions and the result was x, then we can then assume that f of x and g of x are inverses of each other. So today we're going to try to find out, if we want to find the inverse of f, what is in fact f inverse? So it's a pretty simple process. Let's take a basic function here to start with. We'll do a quadratic f of x equals x squared plus 5. And I'm going to go through a couple different options you have for determining the inverse. You have the algorithm, the mathematical way, where just remember f of x is the same as y. So y equals x squared plus 5. And recall that graphically, an inverse function is reflected over the y equals x line. And we've mentioned that as far as the points are concerned, that if you reflect over the y equals x line, we are switching x and y. Well, algebraically, the same logic holds true. So we're literally going to switch x and y here and say that x equals y squared plus 5. And now I'm going to resolve for y. So x minus 5 is equal to y squared, and y equals plus or minus the square root of x minus 5. So officially then, f inverse of x, that's our notation, f inverse with that little -1, there f inverse of x is equal to plus or minus the square root of x minus 5. And we can always quickly check that by composing those two functions, and remember our result should be x. So if I take f of f inverse of x, and it really doesn't matter if I choose the plus or minus. Remember, this is 2. If we think of this graph here, the square root of x minus 5, we are shifted to the right 5, and we look like that. And negative square root of x minus 5 is just the piece below it, reflected over the x-axis. So if you think about it, that's our sideways parabola. However, that is not a function, obviously. It would not pass the vertical line test. So that's why I've split into two separate pieces, a positive root x minus 5 and a negative root x minus 5. For our composition purposes, it doesn't matter if we choose plus or minus, so I'm actually going to write them both in there. So the square root of x minus 5 squared, right, because we're plugging back into the x squared, plus 5. If I square a square root, I get x minus 5. The square root and the squares cancel out. And plus or minus, it doesn't matter because my result's going to be positive anyway. So I get x minus 5 plus 5, which equals x. We have confirmed that indeed it is an inverse. Let's try one more example here of inverse functions. Let's say f of x is equal to 4x minus 5. Again, recall f of x is the same as y. So I will simply switch my x with my y and resolve. So we get y equals x minus 5 over 4. And remember, since f of x already is y, we can't have two different things saying y equals when they're clearly different. So my final step then is to replace y with its new name, f inverse of x, which says it's x minus 5 over 4. And you can compose them if you'd like and see. You can even logically see this. If I plug x minus 5 over 4 in here, the 4's will cross out. And then the minus 5, oh, as I see I made a mistake, that's a plus 5 there, correct? This should say x plus 5, and finally plus 5. And now you'll see the plus 5 and the minus 5 will cancel out. Now I mentioned there are two ways. This is the cut and dry algorithm way. Your other option is logic. Follow your order of operations. The first thing I do is I multiply x by 4. The second thing I do is I subtract 5. So an inverse undoes your function. So to undo this, the first thing I'm actually going to do is add 5 to x, because adding undoes subtracting. And the second thing, instead of multiplying by 4, I will divide by 4. And you see our result would be, first thing, add 5. Second thing, divide by 4. Boom. Same inverse we got. And we can apply that same logic to any kind of function, really. If we want to take y equals, let's do 2x squared minus 3. So order of operations, the first thing I do is square the x. The second thing is I multiply by 2, and the final thing is I subtract 3. So if I'm inverting this, the first thing I'm going to do is add 3. The second thing is divide by 2, and finally, to undo squaring, I square root there. So I end up with x plus 3 divided by 2, and I'm square rooting that. Sorry about that ugly square root. Let's try that again. And technically I need a plus or minus there for that one. Okay, and again, if you compose, you can see the square and the square roots cancel, the 2 and the divided by 2 cancel, and the plus 3 and the minus 3 would cancel and be left with x. So there are our inverses and how to find the inverse function. The final piece of today is a topic called one-to-one. One-to-one is very similar to the vertical line test. We saw a couple examples very quickly here with y equals x squared plus 5. And we also noticed that when we took the inverse of that, remember, we switched x and y. We mentioned it was a reflection over y equals x. And we got this little guy here. We said it was the top half of square root of x minus 5 and the bottom half of square root of x minus 5. Well, if this guy here is f of x, and this guy here is f inverse of x, it's clear to see that f of x is a function. F of x is a function. But f prime of x, f inverse of x is not a function. And that's because of our vertical line test. Well, we have a little trick that we can do to the original function to determine ahead of time if the inverse is going to be a function or not. And if you think about it, it really makes a lot of sense. If we do a vertical line test, which is a line of x equals, right? X equals is a vertical line. If we're testing a function by using a vertical line test, and we find the inverse by flipping x and y, it stands to reason that if we flip our vertical line and turn it into a horizontal line, a y equals instead of an x equals, we can then test if something passes the horizontal line test. Clearly, the parabola does not pass the horizontal line test, and therefore the inverse will not pass a vertical line test since x and y were being switched. So if a function passes the horizontal line test, then its inverse will pass the vertical line test, therefore being a function. Thank you.